With these ideas, we can now look at what goes wrong when we have a buffer overflow. So we're at the point where we're inside of f and moving towards calling getS, but first we make room on the stack, and that room is for local variables like name. So let's suppose that the name local variable is put here. I'm showing name as occupying 2 words, or 16 bytes, even though we only need 10 bytes for name, but it's often the case that these sizes are rounded up to match a multiple of the word size. So let's imagine that name really starts here, and there's an extra few bytes at the end of name that would otherwise be unused. When we call getS, this address, the start of name here, is passed into the function. And if we said hello just to MSD, then that would fill in MSD, and then I'm writing \0 for a null byte. It would be only 3 bytes, which fits comfortably in our 10-byte buffer here. If we type Rumpelstiltskin in as the input, that turns out to be 16 bytes, 15 letters, plus a null terminator, and that is too big for our buffer, but it happens to work out, and this explains why Alice and Bob, which is between 10 and 16 bytes, tends to work out, even though it shouldn't. In other words, this is illustrating the unlucky case, where we have in fact done something undefined in C, but the anything that could happen is that the program seems to work just fine. We have overflowed the buffer, but it prints hello Rumpelstiltskin and returns without crashing. If we type something much longer, like the 20 bytes that I'm showing here, plus a null terminator, now we've overflowed the buffer, and notice that as we keep writing into that name buffer, we have overwritten the return address that used to be there. So that is going to be the key to the problem here. We've written some user input that had the effect of changing an address inside the program's operation. These bytes that we wrote here are eventually going to be interpreted as some address to jump to, and it happens to be these hex digits here, which will refer to who knows what. But it doesn't go wrong right away, because getS returns successfully by popping this address off the stack. If we had a call to printf here, it could go along just fine and say hello to that large 20-byte name. The problem, though, is that when we try to return a second time, now we are going to be using this address that was overwritten earlier, and it will jump into some unknown code. Ideally, nothing is at that address and we will crash right away, but it might be some code that actually is in memory and does something sensible for some mode of operation of the program, but not sensible or expected at the point where we're returning from the function f. It might even be that the address we write here refers back into the stack, and it could be that the input that was crafted for the program not only overwrite the return address here, but it overwrote it to go back to some machine code that was in other parts of the input that will get executed.